Hello everyone, hope you're doing good. My name is Ratasha and today we'll discuss about network switching techniques. Without any further ado, let's get started. The topics that will be covered in today's presentation are: firstly, we'll be discussing what is switching, and then we'll be covering upon what are the different network switching techniques, and then we'll be discovering about the differences between these different network switching techniques, right? So let's get started. So we all know that a switch is basically a dedicated piece of hardware that facilitates the process of switching, right? Now what is switching? It is nothing, it is just the process of transferring the incoming data to a respective destination device, right? So a switch facilitates the process of transferring the incoming data to the destination, right? And this process is simply known as switching, right? Now the process of switching basically involves four steps, right? These are frame reception, MAC address extraction, forwarding decision and switching table updation, and frame transition, right? So we'll discuss these one by one. Now what happens in frame reception is, as the data packet comes to the switch, it needs to accept that data packet, it needs to receive that data packet, right? Now this process is known as frame reception, alright? The next process is MAC address extraction. Now, after a data frame or you can say a data packet is accepted by that switch, what it will do is it will find from the headers a header that is responsible for storing the MAC address, right? We all know that the packet has some headers, and one of those headers obviously would have a MAC address, right, of the destination device. So after finding the MAC address, it will perform a lookup from its switching table, right? Why? This is done to find a port that will lead to the MAC address of the destination device, right? Now, there are two possibilities. Either the switch could have found the port from the switching table or it couldn't have, right? The next step is forwarding decision and switching table updation, right? Now, based upon the two cases that I told you above, if the switch would have found the port, simply it would forward the data to the respective port, right? But if it hasn't found the port, what it will do is it will follow the process of flood processing. I'll repeat, it will follow the process of flood processing. Now, what will happen in this process is that it will send the data packet to all the ports except the one from which it has come, and then records the MAC address to which the data frame was actually delivered, right? Now, this will actually help the switch to find the new MAC address and the port that corresponds to the new MAC address, right? And on the basis of this, it will update its forwarding table or switching table as well, right? The last step is frame transition. What will happen in this step is, once the destination port is found, the switch will actually forward the data to that port and deliver the data to the destination device, right? So these were the basics of switching, right? So as you can see in the current animation, switching is nothing, it's just the process of selecting from multiple paths that lead from the source to the destination, the best path, right? The best path in order to send the data from incoming device to the outgoing device, right? So next we'll discuss what are the different switching techniques, right? Now, as I already told you that in computer network, there can be multiple paths from sender to the receiver, right? And the main use of switching techniques is basically to decide the best route for transmission, right? So the process of finding the best route is basically what switching, right? Now we'll discuss different types of switching techniques. So switching is broadly categorized into three types. The first is circuit switching, the second is packet switching, and the third is message switching. Packet switching is further categorized into two more types, which are datagram based approach, and the second one is virtual circuit based approach, right? So we'll start a discussion with circuit switching. So communication through circuit switching basically involves three phases, right? The first is circuit establishment, the second is data transfer, and the third is circuit disconnect, right? So what will happen is in circuit establishment is basically a connection or a dedicated path will be established from the sender to the receiver. This is the first and the foremost requirement, right? The data cannot be transferred without establishing the connection. Now, how is the connection established? So basically, let's take an example that user wants to send the data. It could be a voice or video, data packet, anything. Now what it will do is, it will basically send a request signal to the receiver. And the receiver will basically send back an acknowledgement. After this process is done, a connection is established. After the connection is established, on the same line, the data is also sent. And after the data is sent, the acknowledgement is received that the data is okay, it's been received, the connection will be terminated, right? So these are the basic steps in circuit switching. So we know that a dedicated path between the sender and receiver is established. In circuit switching technique, once the connection is established, then the dedicated path will remain to exist until the connection is terminated. Very important point. Until the connection is not terminated, that path will continue to exist, right? Now, in order to understand this, in order to comprehend this properly, I'll give you an example. Circuit switching is basically very, very much related to telephone networks, right? Because this was actually made for telephone networks. Now, let's take an example of a telephone, right? So, firstly, when you need to call someone, what do? You pick up your telephone, you dial the number, right? This comes under the step of establishing the connection, right? You're sending the call, you're establishing the connection. Now, let's think that the second person, your friend, has picked up the phone as well. Now the connection is established, right? Now what you'll do, you'll continue, you'll start talking. This is the process of data transferring. Your data is being transferred, right? Now let's assume that you told your friend, okay, I need to tell you something important. And your friend tells you, okay, just wait for 2 minutes. I'll come back in 2 minutes, right? But the phone is still on. So what is this? The connection is still established. It isn't terminated. Maybe the data is not being transferred, but the connection is still established, right? So after your talk is completed, you both put the phone back. In this way, the connection is terminated, right? One fact that I would like to tell you is basically we have all studied about TCP, IP, and OSI models. Now, one interesting fact is that this circuit switching technique or concept is basically older than these concepts of OSI and TCP, IP. Because at the time when there was no internet, telephone networks used to exist, and circuit switching is basically meant for these telephone networks only, right? So now let's see a diagram to understand circuit switching in more detail. So here you can see if I need to transfer something from this device to this device, firstly I'll make a connection, and then this connection you can see a red line connection is made, and then these thunders or data are transferred, right? So the first and foremost requirement, establishing of connection, transferring of data, and termination of connection, right? So let's move on to the next technique, which is message switching. Now, what happens in message switching is basically the data is transferred as a complete single unit, which is known as a message, right? And it's not directly transmitted from the sender to the receiver, but it is transmitted through a series of intermediate nodes, right? Each of these intermediate nodes will actually store that data, and then it will forward it to the next device or the next node until it reaches its destination node, right? Because of this process of storing and forwarding, it is also called as a store and forward network, also a hop by hop system. These both names are equivalent to message switching, right? These both names are just another names of message switching. Now, one of the primary requirements is that the message should be appended with the destination address. Otherwise, transferring of message is obviously not possible, right? Also, for storing the data, each node must have a strong capacity, right? Because it needs to store the data. So, a message will only be delivered if the connection is set and the node has all the resources to store the data, right? And what is this called? This is called the store and forward capacity. Now, what will happen is if one of the nodes is not capable of forwarding the data will be stored in the previous node only. It won't be forwarded to the next node until the previous node makes sure that the next node to which I'll be forwarding the data is capable enough, is having the resources, the storage capacity to store that data, right? This helps in the protection of data as well. The data does not, gets disrupted. Now let's look at the picture to understand what message switching actually looks like, right? So if I want to send my message from terminal 1 to terminal 2, and these are the nodes in between, these are the end devices, you can think of them as end devices. This is my message, a complete single unit, right? Now this is being transmitted to this node. SW1 will store that message, right? It will match its MAC address and the MAC address that is written on the header of this message. Now they both don't match, they both don't match, so it will forward the message to the next device, next node, right? and then SW2 will actually forward the message to terminal 2. So this way, the message is reached from the source to its destination, right? Now we'll discuss the advantages of message switching. So basically, because we are having the opportunity to store the message, so actually this can help in reducing the traffic congestion in the network as well, right? Now, there is no need to establish the connection. If you remember, we need to establish a connection in case of circuit switching. But in this case, there is no need at all to establish the connection. Now, what can be the disadvantages? So basically, you know that I already told you that if this SW1 thinks that SW2 is not having enough resources or enough storage capacity, so I won't forward the message until and unless it is capable enough to store the message or it is having the resources. So this causes delay. And in processes that involve real-time data transmission, message switching cannot be used at all, right? Because delay is not acceptable in those, right? So now, let's look at what packet switching means, right? So, in packet switching also, the data is transferred in one go. But then what is the difference between message and packet switching? The difference is that in packet switching, the message is actually broken down or divided into smaller data packets, right? And each of these data packet is transferred or sent individually to the destination device, right? Now, each data packet is actually given a unique identifier in order to identify their order at the receiving end. Why do we need this? Because it may happen that you are sending the data, you are sending 4 data packets, and you want that the first data packet should arrive earlier than the second data packet. What actually happens is that the second data packet actually follows a shorter route, so it reaches earlier than the first data packet. But you wanted that first should have arrived earlier. So the solution to this problem is you could just rearrange them at the destination device. So this is what actually happens in packet switching. Because they have unique identifiers, we can identify their order at the receiving end and we can rearrange them, right? Now, one more benefit of packet switching is that if any of the packet gets missing or corrupted, that packet can be transmitted again, right? Now, if a correct order is received at the receiving end, an acknowledgement will be sent in order to say that, okay, I've received the correct order of data packets, right? As you can see in the animation, this is the message to be transferred, and these are the different packets. They have sequence numbers, they follow a different route, and they will rearrange themselves. See, the last message will be hello, because they rearranged themselves, right? So these are the packets, they have sequence numbers written on them. They will follow different paths and they will actually rearrange themselves as hello. So this is what packet switching actually is, right? Now, there are basically two approaches for packet switching. We'll discuss them. These two approaches or these two types of packet switching are datagram based approach, which is basically datagram switching, and the second one is virtual circuit approach, which is virtual circuit switching, right? So let's first discuss what is datagram packet switching, right? In this technique, each packet is known as a datagram, right? And each packet will contain all the information that is required by the switch in order to forward the data to the correct destination, right? So, because I already told you that each packet will have a sequence number written on it, so it might follow a different route. But when it is received at the destination, it will be reordered. It will be reassembled in order to get the correct sequence, right? For example, if you see in the image, the sequence that initially was sent was DCBA, and at the receiving end, they might have been received in different order, but this has been rearranged to DCBA, right? Now, the path that is followed in this case is not fixed, right? This A could have come from here, could have come from here, could have come from here. So the path is not fixed. So who decides these paths? So the decision of routing is basically taken by the intermediate nodes, these nodes. Because this is a kind of packet switching. So these nodes will take the decision of routing the packets, right? It is also called as connectionless packet switching. Why connectionless? Because there is no need to establish a connection between the sender and the receiver, right? So now let's discuss what is virtual circuit switching, right? Now it is actually a connection-oriented switching technique. So what happens in this case is that a pre-planned route is established before the message is sent, right? So firstly, the data packets will be first assembled and then they will be numbered, right? So they all will be given a predefined route through which they have to travel, and they'll be reaching the, you can say, the receiver in sequence, right? So how is this done? How is this connection established is, firstly, basically this is done with the help of call request and call accept packets, right? So what will happen is the sender will send call request to the receiver. The receiver will then accept that request and send a call accept bit, right? So then a connection will be established, the data will be transmitted, acknowledgement will be sent back to the sender, and then a clear acknowledgement is sent, which actually means that okay, the transmission has been taken place. Now this connection, logical connection, can be terminated, right? And one more thing to note here is that for throughout the duration of that logical connection, the path would be fixed because it has been decided, right? Now, as we have discussed about the different switching techniques, we'll look at the differences between different switching techniques, right? So let's start a discussion with circuit switching. Okay, a dedicated transmission path is required in circuit switching, right? The first point was establishment of connection in circuit switching, right? So it indicates that a dedicated transmission path exists between a sender and a receiver. But this was not in the case of message switching and packet switching, right? Because different rules were being followed in message switching as well as in packet switching, right? Initial call setup is required in circuit switching, but it isn't with message switching and packet switching. Now we all know when I was teaching you about circuit switching, there was no node in between that was actually storing the data, right? So no data storage or storing takes place in case of circuit switching, but it does take place in case of message switching. In packet switching, what happens is the data itself doesn't get stored, but queuing up of packets is still possible, right? So packets can still be queued up, but they won't be stored at all, right? Then the path established for the entire connection. The path is established for the entire connection. Yes, right? Because throughout that connection, the path will be, it will persist. I gave you the example of telephone line that maybe the data transmission is not taking place, but the path is still persisting. So the connection needs to be terminated if that path needs to be released, right? In case of circuit switching. But in case of message switching, that route is established for the entire message, right? Because that message will be transferred through a route. That route could be anyone, but it is a fixed route, right? Then in case of packet switching, for each packet, that route is fixed. Now, for different packets, there are multiple routes, right? They can choose any route. But if it has chosen a route, then that route is fixed for the entire packet, right? Now, in case of circuit switching, no addressing is required. I told you that there's a single connection line. So what's the need of addressing in circuit switching, right? So no addressing is required. But in case of message and packet switching, we know there are different routes. The messages or packets can be arriving from different routes. So they need addresses. They need the address of the destination device, source device, etc. Right? So this was all. Thank you so much for watching the video.